Welcome to 1.3, Evaluating Limits. Evaluate here means calculate. There are different ways you can calculate limits. Sometimes you can factor. For example, in 1.2, in our last lesson, we saw this limit, the limit of x squared plus 5x plus 6 over x plus 3 as x approaches negative 3. The problem is we can't plug in because we get 0 on top, 0 on the bottom. But we can factor this. We know that x squared plus 5x plus 6 is just x plus 2, x plus 3. And we can just cancel out the x plus 3 on top and bottom. Okay. So when we do that, and we cancel out the x plus 3 on top and bottom, we get the limit of x plus 2 as x approaches negative 3. Now we can plug in. So if you can factor and cancel, do that. Next, this time we have the limit of the function x minus 11 over the square root of x minus 2 minus 3. And we want the limit as x approaches 11. Once again, if we plug in 11 on top and bottom, we end up with 0 over a square root of 9 minus 3, which is again 0 over 0, so we can't plug in. But we can rationalize the denominator. In algebra and pre-calculus, you're expected to fully simplify by getting rid of this square root term on the bottom of our fraction. How do we do that? By multiplying by the conjugate. That means that if we have the square root of x minus 2 minus 3, we can multiply on top and bottom by square root of x minus 2 plus 3. And we do the same on top and bottom. When we distribute the square roots, square root of x minus 2 times square root of x minus 2 just gives us x minus 2. Okay. So when we do that, we get on the bottom, the square root goes away. We just have x minus 2 minus 9. Okay. On top, we would have x minus 11 times the term that we had before. But then, x minus 2 minus 9 is just x minus 11. This means that we can cancel out the x minus 11s. Okay. And now we can plug in. We end up with just square root of x minus 2 plus 3. So when we plug in 11, we end up with 3 plus 3, which is equal to 6. So whenever you see a denominator that has a square root term in it, see if you can multiply by the conjugate and rationalize the denominator if you can. Next, sometimes we can apply properties of limits to evaluate them. The sum, when we add the limits of two functions, we can add the functions first and then evaluate the limit. So the limit of the limit of f plus the limit of g is equal to the limit of f plus g, assuming that x is approaching the same number. Similarly, subtraction, the limit of f minus the limit of g is the limit of f minus g. Multiplication, the limit of f times the limit of g is the limit of f times g. Division, the limit of f divided by the limit of g equals the limit of f divided by g. But this one has a caveat. Caveat means exception, like we have to be careful. Because if the limit of g is 0, then we can't do this because we end up dividing by 0. So as long as g is not 0, the limit of f divided by the limit of g is the limit of f over g. Exponents work. the limit of f to the n power is equal to the limit of f, and then take the exponent to the n power. Why do these work? Well, for example, if we think about the graphs, if we have f of x here, and even if f of x is not defined here, the limit still exists. And if we have g of x, when we multiply f of x and g of x, we can just multiply f of x and g of x at every value on this graph. So even if they're not defined at a certain x, if they're approaching that value, it still works out the same way. And finally, the limit of a here is any constant times f of x. We can put that constant out. It's equal to a times the limit of f of x. Examples. Let's say that as x approaches c, the limit of f of x is 5, g of x is 3, and h of x is negative 2. We can evaluate some limits here. Example 1, the limit as x approaches c, 2fx plus the limit as x approaches c, 3g gx. Well, the limit of f of x is equal to 5, so the 2 can be pulled out, so it's really 2 times 5. Similarly, we get plus 3 times, this is 3 right here, so we have 19. Example 2, the limit of 4gx over the limit of hx squared. All the x's are approaching c. Same thing, so 4 times 3 over negative 2 squared. That's 12 over 4, which is 3. Okay. Finally, limits of composite functions. Composite functions. Let's say we know that f of 3 is 4, f of 5 is 2, g of 3 is 5, g of 4 is 1. We want to find f of g of 3. Okay? Well, f of g of 3, we can type this out again. That's f of g of 3. What is g of 3? G of 3 is 5. So we can replace g of 3, substitute g of 3 with 5. But then f of 5 is equal to 2, so that's it. We don't really need to know what f of 3 is to do this problem. If we know g of 3 is 5 and f of 5 is 2, we can do f of g of 3. The limits of composite functions are really similar. So if f of 3 is 4 again, f of 5 is 2, but this time we're told that the limit of g of x as x approaches 3 is 5, and the limit of g of x as x approaches 4 is 1. We want to find the limit of f of g of x as x approaches 3. It really works the same way. The limit of f of g of x as x approaches 3 is the same thing as f of 5. As long as the limit of g of x equals 5, we can just replace that with the 5. And f of 5 is equal to 2, so we're done. Okay. So that's what we've got.